Hi everyone! I'm going to be talking today about orbitals and electron configuration. Now, this is a super important topic when it comes to the fundamentals of organic chemistry. This is something you should really understand if you want to succeed and go further and do really well in organic chemistry, especially Organic Chem 1 and 2. So let's get started. So what is an orbital? An orbital is like a wave function. That's the more complicated sense to think about it, but you could think about it like a cloud. So there's just these like areas within 3D space where you're going to find a good probability of finding an electron. So there's a few different types of orbitals. I'm going to draw out a couple axes here. And we're going to just do the primary orbitals you're going to need to know for organic chemistry. So here we have our y-axis, this is our x-axis, and we have our z-axis. One important thing to note is that our nucleus is always going to be in the middle here, and I'm drawing it in with this yellow. So orbitals are always centered around the nucleus. The nucleus is where those protons and neutrons are going to be located, and that's basically the matter that makes up an atom, right? So orbitals are going to be where you're going to find your electrons. So in red here, I'm going to draw you a couple orbitals. We're going to start off with our simplest orbital, which is our 1s orbital. This is literally the most stable, the smallest orbital, and it is most centrally located towards that nucleus. Your electrons are going to be within this red circle, so in this area here, okay? With a 2s orbital, our second most stable orbital, it's going to be about double the size. That's huge. It's going to be about double the size of your 1s orbital. These orbitals are the most simple because they're just these one singular lobe. They don't have two separate areas where electrons can be found. One important thing to note is that electrons are always found towards the center of the nucleus. This is because the nucleus is kind of like hugging onto the electrons, right? So the closer they are to the nucleus, the more stable they are. The highest probability of finding an electron is going to be closer to the nucleus. Now we're going to get a little bit more complicated here, right? This is where we get into our orbitals. So these are called our 2p orbitals, all three of these. We have three different kinds of p orbitals. You have a 2px, which I'm going to draw here. So I'm going to draw one lobe of the orbital in red. So it's called 2px because it's a p orbital. So p orbitals typically have two lobes. So there's not this one circular round area of space. It's going to be this kind of elongated circle. Remember, this is three-dimensional. It's hard to depict this on a 2D surface, but this is three-dimensional. So you're going to have this kind of oblong area of space located along your x-axis. So, this is our x-axis, right? This is our, this is our z, and then this is our y. So this is why it's called the 2px orbital. X, okay, because it's on our x-axis. And these p orbitals have two separate lobes. So I'm going to draw them in, the other half of the lobe in purple here. Okay. Now you have to remember that both of these lobes, they are the same orbital. They're just two separate lobes, like two separate regions, two separate areas where you're going to have the highest probability of finding an electron. And then we can move on to our Z axis. So this line here is like protruding out towards you. So you're going to draw your lobe on, like so. And you're going to have your opposing lobe going back into the page. So feel it, like pretend like this is going back into the page, right? And I'm also going to draw my Y-axis, or my Y orbital, which is it protruding up and down into space. So this is this one here. This is our 2pz. And then this one here, this is our 2py. And I want to emphasize this again. This is the regions of probability where we're going to find an electron, okay? So each orbital can contain up to 2 electrons, and that goes for all orbitals, basically. So I'm going to draw my orbitals in with this. Let's do this light blue color. Oh my god. So our electrons are going to be like this, and you know our electrons come in pairs like this, right? Oh, really bad. Our electrons come in pairs like this. They're these 2 little arrows with just one like arrowhead. And they're so they're paired because they have opposite spins. So one has half spin and the other one has negative half spin. So they're opposite spins. Same thing goes for this 2s. And remember, this 2s orbital is just about double the size of the 1s orbital. And you'll have to remember, this makes a difference because these electrons have a higher probability of being further away from the nucleus than these 1s electrons. In our p orbitals, remember, this is one lobe and this is the other lobe. They are the same orbital. So 1 electron goes in each lobe. Same with this one, and same with this one. So a maximum of 2 electrons can fit into 1 orbital. Now we can use electron configuration to help us like note how many orbitals, or find out how many orbitals an atom is going to have. This is something you 100% need to know in organic chemistry. They will definitely ask you about electron configuration, or at least in general chemistry, they will. So let's start off with, let's do yellow here. You always start with your lowest energy or your most stable. So this is also a very important note. You should know this, and this is one thing you're going to remember from this video is that when you have an increase in energy, you have a decrease in stability. This is so important. It will help you decipher how molecules are going to react and if molecules will actually react. So when you have low energy, you have more stability. Okay, very important. Remember this. I'm going to get rid of it because I need the space here. But so you start with your lowest energy orbital, right? And you remember that's going to be our 1s orbital. So you're just going to draw a little line here, and eventually we're going to put some electrons here. And you're going to remember that only 2 electrons can fit in each orbital. That's why 1, 2, okay? And then you can draw another line here. This is going to represent our 2s orbital. And we're going to go up again, and we're going to draw 3 lines. These are going to represent our p orbitals. And now if you go back up here, we have 1, 2, 3 p orbitals. That's why we're drawing 3 lines. So we have our 2px, our 2pz, and our 2py. And usually you're going to have an arrow on the side going up like this. This is going to tell you that the energy is increasing as you're going up in orbitals. So let's do an example here. We know oxygen. It has how many electrons? It has 8 electrons. So we're going to fill in these orbitals. And let's get started. So we have 1, 2. Then we have 3, 4. And then we have 5. And before we put our paired electron down like that, we're going to move to the next orbital. So we're going to go 6, and then 7, and then here we go, we have 8. So you never, when you have more than one of the same kind of orbital, or same shaped orbital, kind of like these 3 here, you're going to put your electrons in separately, and then you're going to spin pair them. And then we can erase these, and let's do another example with, let's stay the same here, nitrogen. Nitrogen has 7 electrons. So if we implement those, we can do, we'll do 1, 2, 3, 4, 5, 6, 7. So the p orbitals have no paired electrons. So you'll probably get tested on how to write out electron configuration. So you can do it this way, where you're looking at it, and you're going to start from the bottom and go up, right? So for nitrogen's electron configuration would be 1s. And then how many electrons do we have in the 1s orbital? We have 2. So we're going to put a little superscript for 2. It's really bad, but let me rewrite that. 1s2. And then we can move up to our 2s orbital. We have 2s. How many electrons are in our 2s orbital? We have 2. And then we move up to our p orbitals. For these ones, you don't need to write out like 2px1, 2pz1, and so on, right? You don't need to do that. All you have to do is write out 2p and how many electrons can fit in the total of these 3 p orbitals. So if 2 electrons can fit in each orbital and we have 3 p orbitals, you're going to be able to fit 6 electrons. So in this case, we only have 3, so you're going to write 2p3. So this is the electron configuration for nitrogen. And if you remember, we can go back. If you remember for oxygen had the 1s2, the 2s2, and then we had 4 electrons up here because you remember we had that extra electron in our x orbital. So that's going to make 2p4. If you don't want to draw out this whole crazy diagram, you don't have to. There's a little cheat sheet hack, which I'm going to do over here. You start off by drawing all your s orbitals. Not even drawing, just writing out. We have 1s, 2s, and make sure to put your little 2 there. 3s, 4s, 5s, and then you don't, oh, I drew an s for that one. And then you don't really need to go any further. You really don't even need to go below 3 here, but it just makes it simpler for if they just throw a random like halogen at you or something that's lower down in the periodic table. And then there are no p orbitals in there's no like 1 p orbital. There's no 2, oh sorry, there is 2 p orbitals. Okay. And then so you don't have to put anything beside 1 because there's no 1 p orbitals, but there are 2 p orbitals. So we're going to put 2p. You can fit 6 electrons, right? Same with 3. We have 3p6 orbitals, 4p6, 5p6. And then there's also d orbitals, like 3d10. So there's there's 5 d orbitals in which you can put 2 electrons each. So that makes 10 electrons total. Same for this one here. And we won't go any further than that. Also just drawing a 6s2 to make it look a little bit nicer. I'm going to go in with the red here, and I'm going to show you how you can go through these orbitals. So you're going to start at 1. This red is showing you where to start. You always start here, 1. So you go diagonally down. You count your 1s, you count how many electrons will fit in your 1s orbital. Of course, we have 2 electrons in our 1s, right? And then we go down again to 2. So this is where you're going to go for your second time. And then you're going to go down across. This is where you're going to go for your third time, your fourth, your fifth, and your sixth. So let's do fluorine as our example here. So fluorine has 9 electrons. You get your number of electrons by their atomic number, okay? Their atomic number is 9. Oxygen's atomic number is 8. Nitrogen's atomic number is 7. So fluorine comes right after. It's at number 9 on the periodic table. So if we're going to do its electron configuration, we're just going to count. So we're going to have 2 in our s orbital, in our 1s orbital. So now we have 7 left. Then we have 2 in our 2s orbital. So now we have 5 left. And we move on to our 2p orbital. And we don't have 6, but we do have 5, so we'll put 5 there. So that's the electron configuration for fluorine. Super simple. And same with this, you can also tell how the energy is going to be increasing or decreasing just by way of drawing an arrow. So here, you're going to have your energy, it's going to be increasing in the opposite direction of this one, kind of flipped around. So your energy, this is your most stable, right? Your 1s is the most stable. And down here, your 6s is going to be your least stable. And all of these in between, like solely, this is going to be your second least stable, your third least stable, your fourth least stable, going all the way up, okay? And when you do draw these diagrams, this can help you understand how many valence electrons some molecules will have. Let's look at nitrogen here. A rule of thumb in organic chemistry is something called the HONC rule, which is how many lone pairs an atom's going to have and how many bonds an atom's going to make for it to be the most stable, right? So nitrogen has 5 valence electrons, these 5 here. And you see how these ones don't have a pair. They're all lone, they're single, they don't have like a lover. They are going to be your your electrons that are going to want to bond the most. And you see how this one here, it has a pair. It's solid, like it doesn't feel like it needs anyone else, right? So this is going to be your lone pair. So when you're drawing out an atom, your lone pair doesn't really participate in bonding because it'll make the atom unstable, right? It'll make it electron deficient when you bond one of these, which is like a positive charge, okay? So let me just draw that again. Your nitrogen. So this is your lone pair. These, I'm going to draw this out for you. So these 2 come from your 2s orbital. These ones are all in your 2p orbitals, okay? So these unbonded, these unpaired electrons are going to want to form bonds with other things, like so, which is kind of how you get these. If these lone pairs bond, it'll make the atom unstable. and it'll want to just get rid of that bond. So in general, your total molecule will kind of be unstable. Say you have NH4. You're making it unstable now. You're giving it a positive charge. It's electron deficient because these lone pairs are no longer bound to each other. Now it has 1 electron extra. It doesn't like that. It really just, it would rather not have that. So it's going to want to shed. It'll just easily shed. This is why this is a base. It'll easily shed. It will easily shed this extra hydrogen to get back to its most stable form again. Now, I don't expect you to really understand that if you haven't taken organic chemistry, but we will go through that on my channel eventually. And I will show you how that kind of influences the stability of molecules and the acidity of molecules. Anyways, I feel like this is really the key to understanding organic chemistry and why atoms will bond to each other, which is the whole kind of premise of organic chemistry. Almost all organic molecules will follow this. So that's the end of today's video. We went over orbitals, their configurations, and also electron configurations and how to find valence electrons, how to find stable electrons, and just a little sneak peek into lone pairs and bonding, basically. But that will be for another time in another video. I hope you guys enjoyed this video. If you have any questions, you can leave it below in the comments. And thank you guys. Have a good day.